19 million people live in California. That's one-tenth the population of the 50 states, but only for this month. Next month, there will be 10,000 more. Next year, 1/3 million more will live in California than last year, enough to populate a good-sized city. We are addicted to the automobile. There are 11 million registered cars, trucks, and buses traveling the highways of California. But by 1980, there will be 20 million vehicles in California alone. Not all the population increase in California is due to the birth rate. Migration is a large factor. The rate of migration into this state is almost 400 people per day. Many families come to visit and stay to orient their lives by the automobile. New people mean new housing developments, utilities, social services, and automobiles, streets, highways, and freeways. It all began with the gold rush in 1849. Since then, transportation in California has leapfrogged 1,000 years of technology in a century, from frontier paths to urban freeways. This development is not a luxury, but a necessity. The economy and the standard of living depend on the rapid growth of transportation facilities. California is made up of cities able to grow swiftly because the accelerated development of freeways has given them new hearts, new circulation systems. The necessities of living include recreation, and most Californians get to their fun by way of the highways. In California, there are miles of ocean, leagues of sandy beaches, and mountains 3 miles high. Natural wilderness remains, and it is accessible to more and more people because of the automobile and highways. Californians will travel 100 miles for a day's outing, or to go to the ballet some evening, or to the high hills to show their California children what snow is like. For whatever reason, pleasure trips or daily commuting, they move on highways. Highways along the ocean, freeways into the center of a city for a day's shopping, across abundant valleys and through lonely deserts at high speeds. They travel 96 billion vehicle miles per year. That's the equivalent of 500 round trips to the moon every day. This astronomical amount of travel requires an equally fantastic growth in a well-designed highway system. The California Division of Highways, one of the largest and most advanced highway organizations anywhere, maintains a technological lead by fostering radical innovations developed by private industry. Paving a highway used to be a laborious job for pick and shovel men. Now, California builds instant freeways. The 4-lane slip-form paver lays down an unbroken 48-foot wide strip of concrete highway in one pass. This $250,000 machine, supported by a continuous batch mixing plant, produces 550 cubic yards of concrete paving an hour, about twice the amount of pavement produced per day in 1928. The paver is controlled by an electronic panel, guided and turned by a sensing device which follows a taut, carefully surveyed wire. This wire is the only guide. No rigid forms of any kind are used. The result, a highway surface of exceptional smoothness. 4 times as smooth as required in the past. And this is something the driving public appreciates with the speed of today's traffic. The pipe float is a separate, self-propelled unit and follows the paver. The pipe smooths the surface, and a burlap drag gives a non-skid texture to the wet pavement. Several passes are made with the pipe float. All is not lost if edges are missed the first time. The functioning of the paver is largely automatic. Within given bounds, everything is run by $40,000 worth of electronic circuitry. An experienced operator checks for malfunctions and stands ready with manual controls if need be. Behind the success of this operation is a story familiar to engineers: logistics. A steady supply of concrete is precisely dumped into spreaders stationed just ahead of the constantly moving paver. As one truck pulls out, another moves in with more material. At the batch plant, an electronically controlled loader keeps two mixers running, constantly ready to reload the dump trucks with fresh concrete. Constant motion, carefully planned, feeds the 48-foot slip-form paver. These terrible scenes were a scientific test of radio-controlled automobiles deliberately crashed by the California Division of Highways as part of a 10-year program of research. The design of effective median barriers has been one of the principal goals of this program. Various combinations of vehicles, barriers, and driving speeds were made in simulated crashes to obtain data on proper median barrier design. Two types of median barriers have been adopted to prevent high-speed traffic accidentally crossing the dividing strip and causing head-on collisions on freeways. This beam barrier design evolved from the test and is used on narrow median strips. The chain-link barrier, the more effective of the two, requires a wider median. The unraveling chain-link fence dissipates the forward energy of the vehicle and helps to entrap it, to prevent the car bouncing into the traffic stream. With the use of median barriers, we are trading property damage for lives. In many instances, the barrier is the only factor that prevents a head-on crash. Another kind of barrier is this motor-operated lane control fence at the Caldecott Tunnel, a main traffic artery between San Francisco and East Bay cities. The direction of traffic through the central bore is reversed twice daily. The problem of switching traffic direction has been solved by an automatic lane control system of changeable signs, markers, and barriers that can pop up and down out of the pavement at the touch of a button. Further checks and aids are furnished by closed-circuit television. A motorist approaching the tunnel encounters three different kinds of things that warn or guide him. First, changeable signs, then a series of flexible barriers or pop-ups. Finally, a positive barrier to make sure that he does not cross over into opposing traffic. There are 4 signs at each end of the tunnel, remotely controlled to change message lines. Once these messages change, columns of flexible plastic tubing pop up pneumatically, controlled by the same circuitry as the signs. These columns gradually angle across the lane, guiding traffic into the right-hand lanes, closing the left. A final barrier of steel posts and cable prevents vehicles from crossing over into opposing traffic. This system, although seemingly elaborate, saved the larger expense of building an additional tunnel through the mountain for peak hour one-way traffic. Perhaps the best evidence of the complexity of the California highway system, its sophistication, and its functionalism is given by a look at some major freeway interchanges in the Los Angeles metropolitan area. Los Angeles has the greatest freeway system in the world. Several interchanges each move about 200,000 vehicles per day. Why do drivers crowd the freeway? The freeways are swift. Traffic moves at 65 miles per hour, and freeways are safe, 2.5 times as safe as ordinary city streets. Freeways are the preferred routes of travel. While less than 10% of all paved roads in California are freeways, they accommodate almost 60% of all traffic in the state, or will in the next 15 years. Building and maintaining highways in California is truly a big business. The expenditure of nearly $1 billion per year is required to do the job, to keep Californians moving to their jobs and their recreation, to take their products to market, and to bring in needed services and supplies, to ensure a continuous state of progress in America's most aggressive state.